Welcome to The Explainer. Today, we are cracking open the blueprint of an AI's memory. We're going to see exactly how our most sensitive secrets can leak out and, more importantly, how the world's top engineers are racing to lock them down for good.
Okay, so let's just dive right in. We trust AI with everything, right? From our health records to our private DMs. But as all that data gets absorbed into a model's memory, you gotta ask, is that digital brain a secure vault, or is it more like a leaky bucket?
In this map right here, this is our guide. It basically lays out the entire story for us. We'll start with the root cause of the vulnerability. Then we'll get into the really clever attacks people use to exploit it. And finally, we'll unpack the cutting-edge solutions being built to fight back.
So first things first, we need to understand the core of the problem. And honestly, it's not what you'd expect. The really surprising reason these super powerful AI models are so vulnerable, well, it's actually a side effect of what makes them so smart in the first place.
See, we usually think of a data leak as a bug, a mistake, a flaw in the code. But what's so wild here is that in the world of AI, memorizing specific bits of data isn't always a mistake. It's often a feature, something intentionally designed to make the model more accurate and more powerful.
And this really gets to the heart of it. To get that last little bit of accuracy, a model has to learn from everything, including all the rare, unique stuff in what's called the long tail. The catch? That's exactly where our most sensitive, personal information tends to hide. So the AI's quest for perfection is what leads it to memorize the very things we really need it to forget.
Okay, so now let's see how this vulnerability gets exploited. Once an AI has memorized some sensitive data, attackers have come up with three pretty distinct ways to pull it out. This is the heist.
You can kind of think of these attacks as three different kinds of digital thieves. Each one has its own special tools and goals, but they're all after the exact same thing: cracking open the AI's memory vault.
So the first thief is the scout. They don't actually steal the data itself, they just confirm if your specific data is in the vault. It's called a membership inference attack. It might sound harmless, but just imagine a model trained on medical data. If an attacker can confirm your record was in that training set, that could reveal a sensitive health condition. The inference itself is the leak.
The next thief is the artist. Through a model inversion attack, they can actually reconstruct a copy of the original training data. It's like an expert sketching a super detailed portrait of someone they've never even seen just by studying how the security system responds to different questions. This has literally been used to recreate people's faces from facial recognition models. It's pretty scary stuff.
And finally, you've got the safecracker. This is the most direct attack of all: training data extraction. It basically tricks a generative model, like an LLM, into just repeating secrets it was trained on. Attackers use these clever prompts to coax the model into spitting out word-for-word chunks of its training data, revealing passwords, API keys, or personal info just sitting there, waiting in its memory. And believe me, this risk isn't just theoretical. Research has shown that a really simple prompt, just the beginning of a sentence, can cause a model to autocomplete it with real, sensitive information that it memorized. A single query can unlock a private secret.
So, this all leads to the big question, right? How do we fight back? How do we protect the vault? Well, let's look at the new security systems being engineered to defend against these attacks and make these AI models a whole lot safer.
The defenses really fall into two main camps. The first is machine unlearning, which is like surgically removing a specific memory. And the second is differential privacy, which is all about hiding that memory in a crowd so it can never be identified in the first place.
Let's break down these two philosophies. Machine unlearning is a reactive, surgical procedure you do after the model's been trained. Differential privacy, on the other hand, is a proactive, preventative measure you apply during the training. So think of it as a precise extraction versus some really advanced camouflage.
Let's look a little closer at unlearning. In a neural network, you can't just hit a delete key on a memory. The old school way was to retrain the entire model from scratch without that data point, which is unbelievably expensive and slow. So unlearning is the high-tech solution, a set of really clever algorithms that can make a machine forget on command without that massive, massive cost.
And look, this isn't just a technical nice to have, it's a legal necessity. Privacy laws like Europe's GDPR give people the right to be forgotten, which means companies have to delete their data if they ask. Machine unlearning is the critical tech that actually allows AI to comply with the law. Now, the other big defense is differential privacy, and it's often considered the gold standard for prevention. Instead of taking data out later, it builds privacy in from the very beginning. So imagine an AI is learning what a cat is by looking at millions of photos. With differential privacy, it's like adding a tiny bit of static or noise to every single photo. The AI can still learn the general patterns of what a cat looks like, but it can't perfectly memorize any single cat photo, and that's the key. It gives you a mathematical guarantee that the model's output won't reveal whether your specific data was ever part of the training set.
So, where does all this leave us? The reality is, we're in an ongoing standoff. It's this fascinating cat-and-mouse game between the attackers, who are always finding new exploits, and the defenders who are constantly building stronger walls.
And for those of you who want to dive even deeper, the research community has basically laid out a roadmap. This is the essential reading list, covering everything from the foundational papers that first spotted the problem to the latest and greatest on all the defense mechanisms. And that leaves us with one final and really crucial thought. As we keep building these incredibly powerful digital memories, capable of holding the sum of human knowledge, the question of who holds the key and who gets to decide what is forgotten, well, that's becoming one of the most important questions of our time.